Hello, I'm Kazumi, and in this video I'll show you what my custom animation event system can do and a little bit on how it's built. So let's start by answering why I even bothered making it. The main three reasons I made this system was that I wanted for a sure way for my events to be performed without ever having an issue with events getting missed due to frame rate. The second reason was I wanted a way to activate events even if the animation got cut off midway. And the third reason was I wanted to pass more complex data with animation events in an easy way to make it easier to add complex events on animations. Now let's talk about how the system works in general terms. First off, we have the skill scriptable objects, which holds data regarding the animations we are trying to activate, such as the animation state name, the cost of the skill, the animation events themselves, and a follow-up skill, which is optional. Unlike Unity animation event system, the events aren't tied to the animation clip itself, and instead exist on these skill scriptable objects. The animations are activated based on the animation state name on the animator controller, which we fill in on the skill object itself. So if I just play an animation clip normally, no event will happen since the data isn't tied to the clip itself. This could be a disadvantage, but can also be an advantage for certain situations. For example, I can have the same events run on two separate animation clips and I could adjust them at the same place. Because I can set up two different controllers to have the same animation state name, but have different clips inside of them. Okay, we have all this data. What do we do with it? When we try to activate a skill, we send the scriptable object to a script called base skill handler, which take this object, perform checks if it can be activated, and if it can, it will copy all of the events, start the animation, and as the animation progresses, it will check if any events need triggering and will activate them as needed. If the animation was interrupted, it will try to use events that weren't triggered yet if they're marked to be used always. Generally, that's how everything works. Now let's take a look at what data a skill holds, what they can do, and what sort of events already exist in the game. First off is the animation state name. This needs to match with the name of the state in the animator controller. When the skill gets activated, it will look for a state that matches this name. Well, actually, it looks for this cached animation hash and will try to match with this number. As you can see, when I change the string, the hash is changing as well. So while we input the animation state as a string, it's faster at runtime to use a hash, which is why we fill in a string and it turns it into a hash. Eventually, that hash is used to activate the animation. Next, we have two booleans that determine if a skill can be interrupted by other skills and can it interrupt other skills. So let's say we're currently playing a skill that can be interrupted, and a new skill that we're trying to use can interrupt. This will result in the interruption of the current skill and playing of the new skill. If that is not the case, the current skill will continue playing and the new skill will not start. Next, we have skill cost, which can be set to any of the vitals, and you can have multiple of them. Before activating a skill, a check is performed verifying that the necessary vital resources are available. If not, the skill won't start. And then we have events. Events can be of various classes and more can be added when needed. We'll go over some examples, but first, the follow-up. Follow-up is an optional class that allows you to state what next skill should be played after this one. This is needed because, like I mentioned earlier, the animation events aren't tied to a clip. So if we just let the animator controller continue to a new state without activating a new skill, no events will happen. The way it works now is it doesn't automatically start playing the next skill as soon as this one ends, and instead raises an action that sends the follow-up skill as its parameter, and whoever is subscribed to that action can decide if it wants to activate the follow-up skill or not. I mostly use this to string attacks into combos for enemies. The follow-up class also has a calculate total cost, which sums up all the follow-up skill costs, including the current skill cost. It's used to help the enemy AI decide if it wants to start the skill chain with its current resources. For example, the enemy AI would normally wait until it has all the resources to activate the entire skill chain. However, if it has an opportunity to attack, it will start the chain even if it doesn't have the total required costs. So when I press this button, we can see the total cost for all the skills along this chain, which starts with this skill, LA01, and then goes to GS01, which goes to GS02, which goes to GS03. There's also this bool, which when set to true makes it that even if the chain was interrupted, certain events in the follow-up skill would still be performed. Next, we have the preview window. To use it, we just need to select an animator. If the animator controller has a clip that matches the skill state hash, it will automatically find and link the animation clip for us. I wanted to search the animator controller by states and not by clips, but Unity doesn't give that option when searching the animator controller. So if I try to use this on an animator that doesn't have the clip matching the state name, no clips will be attached. But we can still select a clip manually to preview it. Then we have this button here that just moves the scene camera to where the animator is. When we press the animator preview toggle, we can see the animation on the animator in the scene as well as this preview window. Let's take a look at the events now and see what they can do. First off, we have the string event. String event would call a different function depending on the string, and they have the option to always activate, which means when an animation is interrupted before reaching the event frame, we can still activate the event. This is very useful to help avoid situations when states have to be changed during the animation. For example, think about a situation where you perform a grab animation. The grab animation has two events, one at the start to turn you invincible and one at the end to return you to normal. But then the animation got interrupted before reaching the end, and now the player is stuck as invincible. Needless to say, that would be very bad. So this boolean would prevent that. Next up is the damage event, which is used for damaging. A damage event let me decide the damage multiplier for the attack, as well as the poise damage. I can also set how long it will last and if it hits more than once, and how many times between each attack. If I set this value to 0.09 while the duration is 0.18, it will hit twice during the attack. I can also change the origin position for the attack, and the shape of the attack itself by replacing the scriptable object for the cast shape. Let's see how this damage event works right now. If I stand right here, I attack 2 targets, and if I stand here, I attack 1 target. Now let's change the shape into something bigger. I'll use this big sphere cast instead. Now I'm hitting all of the targets. Also, when I use the skill, you can see the skill cost being used as the stamina, mana, and health go down. The next event is the buff event, which can add one or more buffs or debuffs. All of the buff data is contained on the buff object itself. The event just adds the buff. This specific buff is set to expire by time after 30 seconds, and this buff gives you increased stamina regeneration once you go below 50% stamina. And as you can see, while I'm sprinting, as soon as I reach 50% stamina, my regen goes up and I can't go below that. The buff system is a separate system from the animation system, so we won't go any further into it. Next, we have the particle event, which is the flame thing you see on the sword. To set it up, you reference a particle system prefab, then choose how you want it to terminate. By time, by the animation ending, or by the particle system ending. Next, you choose which transform to spawn it at and parent it to. When the boolean parent is null is set to true, after the particle is positioned, it won't be parented to any transform, which is used when you want the particle to stay at the position you spawned them at and not moved with the character. This particle event is linked with this particle object pool, so I won't be creating and destroying things unnecessarily. The final event I'll show is the grab event. A grab event is composed of two follow-up skills, one for the user and one for its target, in case the grab was successful. There's an offset vector 3 field to change the position of the grab target from the skill user local position perspective, meaning if we place the grab target as a child of the grabber, this would be his local position at the start of the grab. There's also a Y angle rotation. So let's say I have a grab that is a backstab. I would set this to 180 so that the grab target would be set with its back to the grab user. Next, we have a hit zone, which is the same as what we saw in the damage event. Just to clarify, in case the hit zone failed to hit anything, the animation will continue without performing the follow-up skills in this grab event. Now let's take a look at the follow-up grab skill for the user. This is how the animation looks. As for the events, I set the user to be invincible during the animation so he won't be interrupted by hits, and I also disable his main collider, because the grab target moves inside of him as the animations are played. Here's how the follow-up skill for the grab target looks. As for the events, first off, we have the self-damage event. The self-damage event uses damage data transferred from the grab user to deal damage to itself. And there's also an event that turns on the ragdoll when the animation is about to hit the ground to look more believable, as well as let the ragdoll system handle getting up from the ground. Okay, let's look at some code, and we'll start with how the skills, which are just containers for the data, are built. First off, we have the core skill template, which is a serialized scriptable object, which is just an Odin version of a scriptable object, so that Odin serializes some of the things in the inspector instead of Unity. This class is just a bunch of getters for what every base skill should contain. It has the animation state name and hash, that can interrupt or be interrupted booleans, the skill cost, follow-up skill, and an array of base custom animation event, which is the base class for the events. It also has this abstract function that is meant to calculate the total cost for a skill chain. Next is the core skill class, which implements most of the fields required by the core skill template. So we have the animation state name and hash, the booleans for the interruption, the skill cost array, as well as a follow-up skill, which is Odin serialized. This attribute makes it serialized by reference instead of as a part of the class, which means it can be set to null and not take space in case it's not used. If you don't have Odin, you can get a similar result by using serialized reference. I like the Odin one better, so I use that one. If you were wondering how I convert the animation state name to hash when I change the name of the string in the inspector, it works like this. The string field has an Odian attribute called onValueChanged, which calls a function whenever the field value has changed. In the function called, I use an animator function called string2hash, which takes in a string and returns an int hash. If you don't have Odin, you can call this function from Unity function event, onValidate, which gets called every time something has changed in the inspector. Down here we have some functions that calculate the total skill cost, but I'm not gonna go into how it works. Here is the first usable skill object, which is called basic skill. It inherits from the core skill, and all it adds is a base custom animation event array and implements the getter for it. Before explaining why it's built like this, let's take a look at what the events look like, starting with the base custom animation event. The base custom animation event is the root class that all events inherit from. All this class has is an event, start frame, and a getter for it. Then we have this class that inherits from it and adds the bool event always activate. Some event class inherit from it instead of the root class. This boolean will ensure that the event is always used even if the animation was interrupted before the event frame was reached. One event that inherits from it is the string custom animation event. And as we can see, it has that toggle. Not all events need that functionality. For example, the damage event, design-wise, would never need to be called if the animation was cancelled before reaching the event frame. So the damage event inherits from the base custom animation event. Let's get back to the base skill. You might be wondering why I didn't put the animation event array as part of the core skill and just use that class instead. The reason is I have a filter, which is an Odin attribute above the field. This filter limits the type of base custom animation event that you can select in the inspector to add to this array. I have three types of skills object: the base skill, which is this one, damage skill, and charging skill. All of them inherit from core skill and implement their own array for the animation events with their own filter. Let's take a look at this damage skill. As you can see, I have different classes in my events. A lot of string events, a melee damage event, and then a self buff event. When I try to add a new event, it will show me all the available classes I can add according to the filter. Since this is a damage skill, we can add melee damage events. Now if we take a look at a basic skill, we can see that we can't add damage events. That's what the filter does. The reason I have different types of skills is because there are different behaviors I need to deal with. A damage skill, for example, calculates and caches damage numbers before reducing the cost of using the skill. A charging skill has a charge time, and when that charge time ends or the input released, will play its charging follow-up skill without external input. Now you know why there are different types of skills and why the custom animation event array exists on them separately. But why do I have the core template skill class, which is just a bunch of getters? The reason for that is because I wanted to have an object that would reference a skill but would override its follow-up skill. The need for that arose when I wanted to swap one animation follow-up to diversify a combo chain. Let's say I have a combo which is composed of 3 different skills, and now I want to change the middle skill so the first and last skills stay the same, but the middle changes. I don't want to create duplicate object of the first skill just to change the follow-up and then have to update both instances every time I wish to make a change to that first skill. That would be cumbersome. So I created an override skill object for the follow-up, and here's how it looks. It takes the original skill and lets you put a new follow-up. Let's look at some code. This is the damage skill class. It inherits from core skill and also implements an iDamage skill data interface, which is just added data for damage skills. The override class for damage skill class looks like this. It inherits from the core skill template class, which is just a bunch of getters, and implements the same iDamage skill data interface, which is just a bunch of getters. It has a reference for a damage skill and a reference to a follow-up of its own. And now, instead of having the properties required by the core skill template and interface pointing to fields from inside the class, they point to field inside of the referenced damage skill. I do that for all the properties except for the follow-up, which is what I want to override from the referenced damage skill. Here's a diagram showing the class's structure. To summarize, skills are just data containers on how each animation operates, and inside of them they have events that hold specific data that is needed for the logic to perform that event. So let's take a look at the logic that uses all of this data, and that is the base skill handler class. There's a lot going on in this class, so I'll try to explain the core of it all and not get into too many specifics. Let's start with how a skill activation happens. Skill activation starts with the try activate skill function, which returns a boolean. This function takes in a core skill template and bool, which defaults to false. First, we check the skill is null. Then we check if the resources required to activate the skill are available. Then we check if a skill is currently active. If a skill is active, we check if the bool disregard interrupt bools is set to true. If it's true, we interrupt the current playing skill. If that boolean is false, then we check if we can interrupt according to the skill booleans, the ones we saw here. The can be interrupted and can interrupt. Inside the try interrupt function, we call the can skill interrupt function. We give it the new skill as the interrupter and the current skill as the interruptee. If the interrupter can interrupt is true and the interruptee can be interrupted is true, then the function returns true, and we can proceed to interrupt the current skill and return true. Otherwise, it returns false. If we manage to pass all the checks, we then return the activate skill function, which also returns a boolean. The activate skill function first tries to find an animation layer for the new skill. It iterates over all the layers in the animation controller and checks if the layer has a state matching our skill animation hash. If we didn't find a layer, we throw an error so we'll know that we set up something incorrectly in the inspector. Next, we check if the skill is currently active and interrupt it if so. We perform this check in here as well because this activate skill function is not only called from the try activate skill function. Next, we assign some class variables for the layer and skill hash. Then we reset certain variables on new skill activation. These variables are mostly related to keeping track of the animation clip progression, such as current frame, previous frame, and frame amount. The skill frame amount is there to solve a problem when trying to activate a skill that was just activated, which is caused by trying to loop the skill by calling it once it ended. Next, we update our current skill. First, we set our current skill class variable to the new skill, and then we copy the animation event from the skill to a list inside the class. This function takes a core skill template and copies the event from it to a list of custom animation events within the skill handler class. We just do add range and that's it. After that, we check if the skill also implements one of the interfaces. If the skill implements an iDamage skill data interface, it will cast it into that and call it damage. Next, we assign our class damage skill variable to damage and register the damage events. In this case, we use an overloaded version of the function that registers damage skill events. I won't go over the charging skill, but to summarize, we always cache the basic skill and basic events, and then we perform extra steps according to the interface. After updating the skill, we can consume the skill costs, because in update we cached our damage and now it's safe to consume the resources. I do it in this order because let's say we have an attack that does more damage when your HP is high, but also consume your HP when you use it. By doing it like this, we make sure the damage doesn't get distorted. Next, we reset the delta position. We do that because sometimes when you interrupt an animation or transition between two animations, there's a spike in the delta position from the animator. Let's take a quick look at this. This is the animator hook class. It sits on the same object as the animator because it needs the onAnimatorMove event call. This class purpose is to cache and alter the delta position and delta rotation values from the animator for other classes to use. And when calling this function, it set the reset delta position boolean to true. So on the next onAnimatorMove event, it will reset the delta position vector to 0. Next, we also reset the delta position multiplier to 1. Its name is pretty self-explanatory. What it does is multiply the delta position by that value. I change this value when I want an animation to move more distance, and I reset it on new skill activation and on ending. This next line refers to looping animation, and I won't go into that. Finally, we activate the animation, and all it does is call the animator crossfade in fixed time function, as well as set some booleans to true. Next, I trigger first frame events. If an event frame trigger is set to 0, I don't want to wait for the animation transition to actually happen and simply activate it as soon as the skill activation happens. We'll go over that function when we get to it in the update function. So let's go start looking there right now. In the update function, we first check if we have a skill currently active. If we don't, we have nothing to do here, so we return. Then we try to get which frame we're at the animation currently. First, we check our animator layer is a valid layer. Then we get a clips array for the current played state on that layer. Just to clarify, the way this system is set up isn't meant to handle blend states with animation of different lengths. That's because when activating a skill, we look for a state, and we don't iterate over all the clips. It can work with a blend tree, but it doesn't know which clip of the blend state it's supposed to handle, and would default to the first one. This might cause the system to think a skill has ended if the first animation of the blend tree is shorter than the others. I might add support for that in the future, but for now there's no need since I want my blend state to have around the same length and the same events happening at the same time anyways. When trying to get the current frame, we always look at the first clip in the array. We now get the state itself and make sure the name of the state matches the one at the skill. We do this because we might still be in an entry transition to the state, and the current state the animator has at the moment hasn't changed yet to our skill state. If that's correct, we calculate the total frame amount and the current frame and return the frame. Next are more things regarding looping skills. And finally, we try to handle event triggering with our current frame. As we saw earlier, we added all the skill custom animation events into a list named animation events. In this function, we iterate over this list and try to trigger events based on the current frame. First, we check if the event needs triggering with this function right here. All it does is check if the current frame is greater or equal to the event triggering frame, meaning the current frame has already passed the trigger frame. Then we try to trigger the event by calling this try_trigger_type_event function. This function is basically a switch with pattern matching. It will cast the event into the type it is and call a specific function that handles that type of event. Let's take a look at the particle event. This function gets sent a particle event parameter, and then it calls the start new particle event function using the data inside the particle event. That function performs different things depending on the particle termination enum, which is in the particle event data class. Once done, the try_trigger_type_event function would return true. If we didn't find an event matching the type sent to this function, it would return false. Once the function returned true, we remove the event from the list and decrement the index. If we didn't get true returned, we throw an error. Next, we try and check if the skill has reached its ending. In other words, did the animation clip reach the end? We perform that with this function that takes in the current and previous frames. If the current frame is less than the previous frame, that means that either the skill has looped or our getCurrentFrame function couldn't find a frame because the state now doesn't match the skill hash and defaulted to 0. So our previous frame is now set to the last frame of the animation, while our current is 0, which means the animation ended. Another check we perform is if the current and previous frames are equal, which can happen in two cases. The first is if the animation reaches its end and it's not set to loop, and also isn't set to transition into anything in the animator, so now it's stuck at the end. The other case can happen when we do a hit lag, which is when we freeze the animation speed for a few frames, and then these values will be equal. Since we don't want to terminate the skill when we do a hit lag, I added this extra check that checks if the current frame is equal to the frame amount of the animation. The reason I don't just compare current frame and frame amounts is because of blend states. If my first clip is shorter than the other clip currently running, and my current frame is higher than the frame amount, I don't want to terminate the skill just based on that. Once we determine the skill has ended, we cache the current skill and then call the stopCurrentSkill function. The important things that happen here are that we run through all the unused events with this function. We iterate over all the events still remaining in the list. We check each event if it is of the class event with the toggle always activate, and if that toggle is set to true. If it is, we will try triggering it with the switch function we saw earlier. After that, we just clear some references and return particle system to their object pool. If the skill was interrupted, we perform some extra steps such as try to use follow-up skill events. A follow-up skill can be set up to have its own events used even if the chain was interrupted. And then we try to call a new state, and what it essentially does is call an empty state without a clip in it, called new state, which I have on every layer except for the default layer. That's all for the stop current skill function. Back here, because the skill wasn't interrupted and ended naturally, we try and use its follow-up skill. If there wasn't a skill to follow up, we invoke the skill chain action. Lastly, we set the previous skill frame to the current frame. That's all for this one. Thanks for watching. If you have any questions, leave them down below and I'll do my best to answer them. And may all your bugs turn into features.